Question 1.1 consists of 5 measurement questions that were designed to assess your ability to read and calculate time. You are given a set of analog and digital clocks showing various time. You have to use this information to answer the questions that follow. In question 111, you have to write down which one of the following options X, Y, or Z best describes the time displayed on each clock, where X being 9 minutes to the next hour, Y being 45 minutes to the next hour, and Z being a quarter to the next hour. The one option that describes the time displayed on each clock will be Z, a quarter to the next hour. In question 112, you are instructed to name the two time formats used to display time on the clocks. The two time formats used to display the time on the clocks are the 24-hour and the 12-hour format. In question 113, you have to write down in words the time displayed on clock B. The time displayed on clock B is 1:45 in the afternoon. Question 114, you have to write down the number of clocks that clearly indicates the time in the afternoon. From the diagram given, we count 2 clocks that clearly shows the time in the afternoon. In question 115, you are instructed to convert 16 hours and 45 minutes to minutes. Since there are 60 minutes in an hour, 16 hours equals 16 multiplied by 60 minutes in an hour, and this equals 960 minutes. Adding the 45 minutes to this will give us a total of 1005 minutes. So 16 hours and 45 minutes equals 1005 minutes. Question 1.2 consists of 3 maps and plans questions that were designed to assess your understanding of assembly diagrams. You are given an illustration of some steps and instructions to assemble a deck chair. To assemble the deck chair, the wooden pieces are joined together using fasteners, which are screws, bolts, washers, and nuts. There are 32 pieces in a packet of fasteners. Each bolt is secured by a nut and a washer. In question 121, you are instructed to determine the number of type C bolts used to assemble the deck chair. From the information given, we know that there are 32 fasteners. The number of type C bolts can be determined by finding the difference between the total number of fasteners of 32 and the sum of the fasteners that are given in the diagram. This will give us the number of type C bolts of 2. In question 122, you have to state the number of nuts left over after step 1 is completed. From the diagram, we can conclude that 6 nuts labeled E are used in step 1 because all 6 bolts labeled B will be used in the step. That is 3 here and 3 here. Note that each bolt needs a nut. Since there is a total of 8 nuts, the number of nuts remaining after step 1 will be 2. In question 123, you have to name the last piece required to complete the assembly of the deck chair. The last piece required to complete the assembly of the deck chair is the short brace. Question 1.3 consists of 5 maps and plans questions that were designed to assess your understanding of road maps. You are given a road map of the Northwest Province showing destination towns or cities and interleading roads. Note that the destination towns or cities is given by this rectangular shaped key with the name of the town or city inside the rectangle. The national roads are indicated by a capital letter N and north points towards the top of the page. In question 131, you have to identify the type of scale used in this map. The type of scale used here is a bar scale. In question 132, you have to name the province that lies east of the Northwest Province. Since east is to the right of north, we can conclude that the province that lies east of the Northwest Province is Gauteng. In question 133, you have to identify the national roads passing through Vryburg. The national roads that passes through Vryburg is the N14 and the N17. In question 134, you have to write down the number of destination towns or cities shown on the map. From the map, we count 7 destination towns or cities. In question 135, you are instructed to measure in millimeters the direct distance as a crow flies from Bloemhof to Lichtenburg. Using a ruler, we measure the direct distance between Bloemhof and Lichtenburg to be about 39 millimeters. Question 2.1 consists of 6 maps and plans questions that were designed to assess your understanding of floor plans. You are given a seating plan of a restaurant for customers on Annexure A. You have to use this information to answer the questions that follow. In question 211, you have to give one possible reason why this restaurant has so many windows. One possible reason could be to let natural light in. In question 212, you are instructed to calculate the maximum number of chairs available for customers. From the seating plan, we simply count the number of chairs, which is 57. In question 213, you have to determine the number of seats directly facing the wall on the south side. From the floor plan in Annexure A, there is a note that states that the main entrance doors are on the south side of the building. So the seats that are directly facing this wall will be these seats. This equals a total of 13 seats. In question 214, you have to give one reason why the restaurant has couches at the entrance. One reason for having couches at the entrance of the restaurant is so that people can sit while they wait to be seated at tables. In question 215, it is stated that a person at table 18 leaves a seat and walks towards a friend at table 4. She uses the arrowed path shown on the seating plan. You're instructed to use the compass directions to describe a path from table 18 to table 4. The person will walk in an easterly direction, then turn and walk in a southerly direction, and then turn and walk in an easterly direction. In question 216, Norma claims that there are less than 21 tables for customers in this restaurant. You are instructed to state with reason whether a claim is valid. There are only 20 tables because the number 13, which is considered by some people to be unlucky, is left out, and therefore a claim is valid. Question 2.2 consists of 4 probability questions that were designed to assess your understanding of tree diagrams. You are given a tree diagram for choices from a set menu at a restaurant. Your options are 1 protein choice with 1 side order followed by 1 dessert. Your choices of protein are chicken, beef, or fish. Your choices for the side order are either vegetables or salads, and your choices for the desserts are ice cream or malva pudding. In question 221, you have to name the type of diagram illustrated on Annexure B. This diagram is called a tree diagram. In question 222, you are instructed to write down the missing outcome at 222A and the protein choice at 222B. The outcome at 222A is chicken with salads and malva pudding. This is abbreviated as CSM. The protein choice for 222B is F for fish. In question 223, you have to state the number of combinations with beef as the protein. From the tree diagram, the number of combinations with beef is 4. In question 224, you are instructed to determine as a percentage the probability of randomly selecting a meal with malva pudding as the dessert. From the tree diagram, we see that there are 6 options with malva pudding as the dessert out of a total of 12 options. As a fraction, this is written as 6 over 12. Multiplying this fraction by 100 will give us a probability of selecting a meal with malva pudding as a dessert of 50%. Question 2.3 consists of 5 maps and plans questions that were designed to assess your understanding of route maps. You are given a simplified route map of the Los Angeles Marathon in the United States of America. This marathon is 26.2 miles long. Note that the map is not drawn to scale. In question 231, you have to explain the meaning of a route map. It is a map showing the path that the runners will have to follow in the race. In question 232, you have to describe what is meant by map not to scale. When a map is not drawn to scale, it means that there is no ratio between the distance on the map and the corresponding distance in reality. In question 233, it is stated that the runners in the Los Angeles Marathon have to pass underneath a bridge at certain points during the marathon. In question 233a, you have to explain how this is indicated on the route map. On the map, we see that when a road passes underneath a bridge or another road, there is a break in the line of that road. In question 223b, you have to write down the number of times that a runner who completes the marathon will pass underneath a bridge. From the route map, we see that at these locations, a runner will have to pass underneath a bridge. So the number of times that a runner who completes the marathon will pass underneath a bridge is 4. In question 234, you have to write down the general direction in which runners will face when they start in Flower Street. It is given that the direction of north points towards the top of the page. We should remember that east is to the right of north, west is to the left of north, and south is in the opposite direction of north. Now the direction in which the runners will face when they start in Flower Street is southwest. Question 3.1 consists of 4 measurement questions that were designed to assess your understanding of properties of cylindrical and rectangular shapes. You are given the dimensions of a rectangular face of a plastic sleeve and a cylindrical Prit container. In question 3.1.1, you have to calculate the perimeter of the front of the plastic sleeve. You may use the following formula. Perimeter equals 2 times the sum of the length plus the width of the plastic sleeve. Substituting the length of 239 mm and the width of 89 mm into the formula will give us the perimeter of 656 mm. In question 3.1.2, you are instructed to calculate in centimeters the height of the opening or closing part of the Prit container. From the diagram, we see that the total height of the Prit container is 114 millimeters. We also know that there are 10 millimeters in 1 centimeter. So 114 millimeters equals 114 divided by 10 millimeters per centimeter, and this equals a total height of 11.4 centimeters. It is also given that the height of the cap is 2.5 centimeters and the height of the Prit body is 7 centimeters. So the height of the opening or closing part will be the difference between the total height of the Prit and the sum of the height of the cap and the Prit body. This will equal a height of 1.9 centimeters. In question 3.1.3, it is stated that the actual height of the glue in the Prit container is 8.5 centimeters and the volume of the glue rounded to 3 decimal places is 52.346 centimeters cubed. In question 3.1.3a, you have to show how the volume of the glue was calculated if the diameter of the glue is 28 millimeters. You may use the following formula. Volume equals 3.142 times the radius of the container squared times the height of the container. We are given the diameter of the container, but the formula given requires us to input the radius. We know that the radius of a container is half its diameter, so the radius of the container equals the diameter of the container of 28 millimeters divided by 2, and this equals a radius of 14 millimeters. Now we also know that there are 10 millimeters in 1 centimeter, so 14 millimeters will be equal to 14 divided by 10, and this equals 1.4 centimeters. Now substituting the radius of 1.4 centimeters and the height of the Prit container of 8,5 centimeters into the given volumetric formula, and then simplifying the equation will give us the volume of 52,34572 cubic centimeters. Rounding this value to 3 decimal places will give us a volume of 52,346 cubic centimeters. In question 313b, you are instructed to determine, rounded to the nearest gram, the mass of the glue in the Prit container if the density of the glue is 0,82 grams per cubic centimeter. You may use the following formula: density equals mass divided by volume. From question 313a, the volume of the Prit container was given as 52,346 cubic centimeters. Now substituting the density of 0,82 grams per centimeter and the volume of 52,346 cubic centimeters into the formula will give us the following equation: 0,82 equals the mass divided by 52,346. Now multiplying both sides of this equation by 52,346 and then simplifying the equation will give us the mass of the Prit in the container of 42,92372 grams. Rounding this value to the nearest whole number will give us a mass of 43 grams. Question 3.2 consists of 2 measurement questions that were designed to assess your understanding of volume. You are given a graph that shows the volume of water in a toilet system that has been reduced over the years. The picture next to the graph shows a toilet pan with a toilet cistern. You are also given the conversion factor for converting volume in gallons to liters. In question 321, you are instructed to calculate in liters the volume of water used during February 2022 by a family of 5 if each person flushed the toilet on average 4 times a day during the month. Considering only one person in the family, one person will flush the toilet 4 times a day for 28 days in February, which equals a total of 112 times for the month. Since the volume of water a cistern can hold after 1996 is 1,6 gallons, the volume of water used by one person will be 112 times 1,6 gallons, and this equals 179,2 gallons per month. Now using the conversion factor of 1 gallon equals 3,785 liters, we can convert the volume from gallons to liters. 179,2 gallons equals 179,2 multiplied by 3,785 liters per gallon, and this equals a volume of 678,272 liters. Now the total volume of water used by the family of 5 will be 678,272 liters multiplied by the 5 members of the family will give us a total volume of 3,391,36 liters. In question 322, you have to state one way in which a person can save water in this context. One way in which a person can save water in this context is to place a brick in the cistern so that less water is used to fill that cistern. Question 3.3 consists of 3 measurement questions that were designed to assess your understanding of time, temperature, and cooking conversions. It is stated that Oma intends baking 2 milk tarts for her friends who will be arriving at 5:30 in the afternoon. She uses the ingredients and information given below. She can only bake 1 milk tart at a time, and while the first milk tart is in the oven, she prepares the second milk tart in order to put it in the oven the moment the first one is taken out. You are also given the ingredients and information for 1 milk tart, and you have to use this information to answer the questions that follow. In question 331, it is stated that Oma would like the second milk tart to be taken out of the oven 15 minutes before her friends arrive. You have to determine the time she must place the first milk tart in the oven. From the information given, we know that the cooking time for each milk tart is 40 minutes. Since we want 2 milk tarts prepared 15 minutes before the guests arrive, we will have to subtract the total cooking time for the 2 milk tarts plus the 15 minutes from the arrival time of the guest. So 5:30 in the afternoon minus 95 minutes or 1 hour and 35 minutes will give us the time that the first milk tart has to be placed in the oven of 5 to 4 in the afternoon. In question 332, you are instructed to convert the baking temperature to degrees Celsius rounded to the nearest 10 degrees. You may use the following formula. Degrees Celsius equals the difference between degree Fahrenheit and 32 degrees multiplied by 5/9. Substituting the value of 325 degrees Fahrenheit into the formula and simplifying will give us the temperature of 162,7 recurring. Rounding this number to the nearest 10 degrees will give us a temperature of 160 degrees. In question 333, you are instructed to determine how many liters of milk Oma needs to bake the 2 milk tarts. From the list of ingredients, we see that she needs 4 1/4 cups of milk. Since she needs 2 milk tarts, we have to multiply this amount by 2. This will give us a total amount of cups of milk needed of 8 1/2. Using the conversion factor of 1 cup equals 250 milliliters, the number of milliliters of milk needed will be 8 1/2 cups multiplied by 250 milliliters, and this equals 2,125 milliliters. Now we should know that there are 1,000 milliliters in 1 liter, so 2,125 milliliters equals 2,125 divided by 1,000, and this equals 2,125 liters. Question 4.1 consists of 2 maps and plans questions and 1 measurement question that were designed to assess your understanding of assembly instructions. It is stated that Itumeleng makes and sells birdhouses at the local flea market. Annexure C shows the diagram of the parts of the birdhouse and the assembly instructions. He uses a single board that is 14 centimeters wide and 20 millimeters thick to make one birdhouse. You are also given a picture of the completed birdhouse. In question 411, you are instructed to show rounded to the nearest 100 that the length of the board needed for a single birdhouse is 1,500 millimeters. On Annexure C, this part of the assembly diagram shows the arrangement of the longest sides of each one of the pieces needed excepting for the floor where the length of the width is used side by side. Using the dimensions given, we can calculate the length of the board needed for a single birdhouse to be the length of the roof of 19 centimeters plus the length of the front of 23 centimeters plus the length of the width of the floor of 10 centimeters plus the shorter side of side 1 of 23 centimeters plus the longer side of side 2 of 25 centimeters plus the length of the back of 41 centimeters. This equals a total length of 141 centimeters. Now we know that there are 10 millimeters in 1 centimeter, so the total length of the board of 141 centimeters equals 141 multiplied by 10, and this equals 1,410 millimeters. Now this value of 1,410 must be rounded up to 1,500 millimeters. Now the reason why we round up to 1,500 millimeters and not down to 1,400 millimeters is because if we round down to 1,400 millimeters, we will not have enough wood to complete the project of one birdhouse. But if we round up to 1,500 millimeters, we will have enough wood to complete the project and a little bit extra, but that's okay. In question 412, Itumeleng stated that in step 2, the 10 cm side of the floor will go against the back. You are instructed to verify showing all calculations whether his statement is correct. In step 2 of the instructions, you are instructed to position the floor between the 2 sides and the back. From the information given, the board has a thickness of 20 millimeters or 2 centimeters. When the sides are placed against the back, which is 14 centimeters wide, The width of the floor against the back will be the difference between the width of the back of 14 centimeters and the thickness of both sides of 2 centimeters each. This will give us the width of the floor against the back of 10 centimeters. Therefore, his statement is correct. In question 413, it is stated that the front part of the birdhouse has a circular hole with a diameter of 4,2 centimeters drilled into it. You are instructed to calculate in centimeters squared the exposed surface area of the front part of the bird box. You may use the following formulae. The area of a rectangle equals the length times the width, and the area of a circle equals 3,142 multiplied by the radius squared. The first step here is to calculate the area of the front of the box before the hole is cut out. The area of the rectangle will equal the length of the front of 23 centimeters multiplied by the width of the front of 14 centimeters, and this equals an area of the front before the hole is cut out of 322 centimeters squared. Next, we will have to calculate the area of the hole to be cut out of the front. From the formula for the area of the circle, we see that we need the radius of the hole. We are given the diameter of the hole, so we need to convert the diameter to the radius. Now, the radius of a circle is half the diameter of that circle. So the radius of the hole equals 4,2 divided by 2, and this equals a radius of 2,1 centimeters. Substituting the radius of the hole into the formula for the area of a circle and then simplifying the equation using a calculator will give us the size of the hole equal to 13,85622 centimeters squared. Now subtracting the area of the hole from the total area of the front of the birdhouse will give us an area of the exposed front of 308,1437 squared centimeters. In question 4.2, it is stated that Itumeleng paints the exposed exterior surface area of the birdhouse. The total surface area of the birdhouse to be painted will be 0,2888 square centimeters. He applies 3 coats of paint according to the spread rate instructions on the paint tin as follows. The first coat has a spread rate of 10 square meters per liter. The coats thereafter requires 14 square meters per liter. Itumeleng stated that he will be able to paint 7 birdhouses with 500 milliliters of paint. You are instructed to verify showing all calculations whether his statement is correct. For the first coat, the spread rate according to the instructions is 10 square meters per liter, and we are given the total surface area of the birdhouse to be painted of 0,2888 square meters. So the amount of paint needed for the first coat will be the total surface area of 0,2888 square meters divided by the spread rate of 10 square meters per liter, and this equals a volume of 0,02888 liters of paint for the first coat. For the second coat, the spread rate according to the instructions is 14 square meters per liter. So the amount of paint needed for the second coat will be the total surface area divided by 14 square meters per liter, and this equals a volume of 0,0206285 liters. The third coat will require the same amount of paint as the second coat. For a total of 3 coats, the total liters of paint needed will be the sum of the liters of paint needed for coat 1, 2, and 3. This will equal the total number of liters of paint needed of 0,070137 liters. Now considering that Itumeleng has a 500 milliliter tin of paint, in order to calculate how many birdhouses he can paint with this amount of paint, we first have to convert 500 milliliters to liters. We know that there are 1000 milliliters in 1 liter, so 500 milliliters equals 500 divided by 1000 milliliters in 1 liter, which equals 0,5 liters. So therefore 500 milliliters of paint equals 0,5 liters. Now the number of birdhouses that can be painted is 0,5 liters of paint divided by a total number of paint needed of 0,070137 liters, and this will give us a total of 7,1289 birdhouses. Rounding this number to the nearest whole birdhouse will give us a total of 7. Since this value equals the amount stated by Itumeleng, we can say that his statement is correct. Not making this last statement will result in you forfeiting 1 mark. Question 4.3 consists of 4 measurement and finance questions that were designed to assess your understanding of income and expense in the context of a manufacturing business. You are given a list of expenses for a birdhouse business and a graph representing the weekly income and expenses for that birdhouse business. In question 4.3.1, it is stated that the equation to calculate the weekly expenses can be written as follows. The expense equals 350 plus P multiplied by the number of birdhouses made, where P equals the variable cost for each birdhouse made. In question 4.3.1a, you are instructed to show how the value of 350, his fixed monthly cost, was calculated. Now, a fixed expense is the cost that does not change from period to period. It remains constant regardless of the level of production or sales. Examples include rent, salaries, and insurance. These costs are fixed because they do not change with the business activities. Now, for Itumeleng's birdhouse business, the fixed weekly expense are the rental of the stall at the flea market of 250 per week, and the transport cost of 100 Rand per week. So the total fixed weekly cost will be 250 Rand for the stall rental plus 100 Rand for the transport, and this equals a total fixed weekly cost of 350 Rand. In question 4.3.1b, you are instructed to calculate the value of P, which is the variable cost of making one birdhouse. For each birdhouse he makes, he will need wooden boards, paint, and some sundries like nails and glue. Now, if he decides to make more birdhouses, he will need to buy more wooden boards, more paint, and more sundries. These costs will increase as he makes more birdhouses and decrease if he makes fewer. This type of cost that changes based on the number of birdhouses he is producing is called a variable expense. It's different from a fixed expense like the rent for his stall at the flea market or the cost for transportation, which he has to pay every week no matter how many birdhouses he makes. Now, for the wooden boards cost, the total cost for a bundle of 6 wooden boards is 287 Rand 40 cents. To find the cost per board, we divide the total cost by the number of boards in a bundle. So the cost per board equals the total cost for a bundle of 287 Rand 40 cents divided by the number of boards in a bundle of 6, and this equals the cost per board of 47 Rand 90 cents. Now the cost for the paint per birdhouse is provided as 21 Rand 40 cents, and the cost for the sundries per birdhouse is provided as 10 Rand 70 cents. Now the total variable cost P for one birdhouse will be the sum of the cost of the wooden board, paint, and sundries together. So P equals 47 Rand 90 cents plus 21 Rand 40 cents plus 10 Rand 70 cents, and this equals a total variable cost of 80 Rand. In question 4.3.2, you are instructed to explain break-even point in this context. The break-even point refers to the point where the total costs, fixed and variable, equal the total revenue. In other words, it's a point in which a business is neither making a profit nor incurring a loss. Now imagine Itumeleng is selling his birdhouses. For every birdhouse he sells, he earns some money. This is his revenue. But making and selling birdhouses also cost him money. He has to pay for his materials like wood and paint. These are his variable costs. And he also has regular weekly expenses like rent for his stall at the flea market and transportation. These are his fixed costs. The break-even point is the exact number of birdhouses Itumeleng needs to sell in order to cover all his costs. If he sells fewer than this number, he will lose money. If he sells more, he will start making a profit. So it's a very important number for Itumeleng to know because it helps him understand how many birdhouses he needs to sell just to cover his costs before he starts making any profit. In short, break-even point is where the number of birdhouses sold equals the expense to make the birdhouse. In question 433, it is stated that during one of the weeks, Itumeleng made 15 birdhouses but only sold 12. You're instructed to show by means of calculations if he made a profit or a loss that week. Using the graph on Annexure D, for the 15 birdhouses he made, his expenses for the week can be read off as 1,550. Also, selling 12 birdhouses for that week, his income can be read off as being 1,800. So the difference between his income of 1,800 and his expense of 1,550 will be a positive 250 rands. Since this value is a positive amount, it means that he made a profit. 5.1 consists of one maps and plan question designed to assess your understanding of infographics. It stated that Danny and Susan are on their way to visit some of the tourist locations in Japan. Annexure E shows a road infographic of their planned tour with the various tourist locations that would be visited. In question 5.1, it is stated that the tourist location details in a random order for the tour are given. That is, A. Start in Tokyo. B. Visit Mount Fuji. C. Visit the world's largest aquarium to see the different types of fish in Osaka. D. At Nara, they plan to visit the large wooden temple and the deer park. E. The Triple N at Ichikushima, which is known for the Great Torii Gate that is standing in water at high tide. And finally F. Drive through Kamakura at a speed not exceeding 40 km per hour. You are instructed to complete the table by inserting the tourist location details in the correct order. Note that the locations of 1 and 6 have already been given in the table, so you have to complete the destinations 2 to 5. Destination 2 will be F. Drive through Kamakura at a speed not exceeding 40 km per hour. Destination 3 will be B. Visit Mount Fuji. Destination 4 will be D. At Nara, they plan to visit the large wooden temple and deer park. Then destination 5 will be C. Visit the world's largest aquarium to see the different types of fish in Osaka. Question 5.2 consists of two measurement questions that were designed to assess your understanding of calculating time. It is stated that Mount Fuji is an active volcano. Its last volcanic eruption was on the 16th of December 1707, and it followed several weeks after an earthquake on the 11th of November 1707. In question 5.1, you have to calculate how many decades ago Mount Fuji erupted. If we consider the present year to be 2022, the number of years from 1707 to 2022 will be the difference between these years. This equals a total of 315 years. We should know that there are 10 years in a decade, so 315 years equals 315 divided by 10 years, and this equals 31,5 decades. In question 5.2, you have to write down the total number of days between the earthquake and the last volcanic eruption. Now we should know that there are 30 days in November. From the 11th of November, which is the day that the earthquake happened, to the 30th of November will be a total of 19 days. Then from the 30th of November to the 15th of December, which is the day of the eruption, will be 15 days. So the total number of days between the earthquake and the last volcanic eruption will be the sum of these two values, which equals 34 days. Question 5.3 consists of three measurement questions that were designed to assess your understanding of ratio, conversion between metric and imperial systems of measurement, and discount calculations. It is stated that in Tokyo, they will visit the Tokyo Tower, which is a communications and observation tower. The tower is 1,092,1916 feet tall and has two viewing decks. The main deck is 150 meters above the ground, and the top deck is 250 meters above the ground. Some of the tickets prices per person are listed in a table. In question 531, you have to write down in simplified form the ratio of the height above the ground from the main deck to the top deck. Since the height of the main deck is mentioned first, this value has to be written first in the ratio, followed by the height of the top deck above the ground. This will give us a ratio of 150 to 250. This ratio can now be simplified by dividing both values by 50, which is the highest common factor between these two values. This will equal a simplified ratio of 3 to 5. In question 532, you are instructed to convert in meters the height of the tower if 1 meter equals 3,281 feet. The height of 1092,1916 feet equals 1092,1916 divided by 3,281 feet per meter, and this equals 332,884 meters. In question 533, Danny stated that if he had been in a group of 60 people observing from the main deck, they could receive a 30% discount on an adult ticket. You are instructed to verify whether his statement is correct, showing all calculations. From the table, we know that the price for one adult viewing from the main deck is 1,200 yen. And the price for one adult in a group of 50 or more will be 916 yen. This is a discount of 240 yen. Now this discount as a percentage will be the discount amount of 240 yen divided by the original price for an adult of 1,200 yen multiplied by 100, and this equals a discount as a percentage of 20%. Since this is not a 30% discount, we have to write that his statement is incorrect. Question 5.4 consists of one measurement question designed to assess your understanding of speed, time, and distance calculations. It is stated on the return journey, Danny and Susan took a train from Hiroshima to Tokyo. The train left Hiroshima station at 6 minutes past 8 in the morning. It stopped at 8 stations en route for 4 minutes at a time. It reached Tokyo at 3 minutes past 12 in the afternoon, and the distance the train traveled was 816 kilometers. You are instructed to calculate the average speed at which the train traveled. You may use the following formula: distance equals speed multiplied by time. Since this question asks us to calculate the average speed of the train, we first have to rearrange the formula that was given so that speed is the subject of the formula. Since the distance equals speed multiplied by time, speed will equal distance divided by time. The units for speed, distance, and time in this formula will be speed in kilometers per hour, distance in kilometers, and time in hours. From the information given, we see that distance is given in kilometers, but time is given in hours and minutes. So the next step is to determine the total time taken from Hiroshima to Tokyo in hours. From the information, the couple arrived in Tokyo at 3 minutes past 12 in the afternoon and departed from Hiroshima at 6 minutes past 8 in the morning. So the total time taken to travel between these two cities will be the difference between these two times, which is 3 hours and 57 minutes. Note here that this time includes the stopping time at the 8 stations. So now we have to calculate the total time the train spent in motion. Since the train stopped 8 times for 4 minutes at each station, the total stopping time will be the product of the 8 stations multiplied by 4 minutes, which equals 32 minutes. Now the time that the train was in motion will be the difference between the total time of 3 hours and 57 minutes and the stoppage time of 32 minutes, and this equals 3 hours and 25 minutes. Next, we will have to convert this time of 3 hours and 25 minutes to hours only. Since there are 60 minutes in 1 hour, 25 minutes will equal 25 minutes divided by 60 minutes in an hour, and this equals 0.416667 hours. Adding this to the 3 hours will give us a total time in motion of 3.416667 hours. Now substituting the value of the distance of 816 kilometers and the time in motion of 3,416,667 hours into the equation for speed will give us an average speed of 238,83 kilometers per hour. Thank you for taking the time to watch this video, and if you found this video helpful, you can subscribe to be notified of more videos like this, and you can check out this video next.